All right, here we go, Mr. Trutna. This is Math 2, Unit 1, Worksheet 2. And what we're doing in this worksheet is we are working on parallel lines and then the special type of angle relationships that happen with parallel lines. So in numbers 1 through 6, we were going to identify each pair of angles as corresponding alternate interior, alternate exterior, consecutive interior, vertical, or adjacent. And like we said in class, we're going to change consecutive interior and we're going to use the terminology same side interior. Okay, all right, so number 1, all we're doing is we are looking at the equation or the angles, and you can see we have the x angle, which is right there, which is definitely on the interior of the parallel lines. And then we have the angle right here that is marked as y, so we have these two angles here and here. Well, you can see that those two angles, since they're both on the interior of the parallel lines, that means they have to be either alternate interior or same side interior. Well, they're not on the same side of my transversal, so number 1 is going to be alternate interior angles. Number 2, we have angle x, which is right there. We have angle y, which is this angle right here. Those are the two sides of angle y, the two sides of angle x. And you can see that the only thing that they share is this vertex right here, so that would make them vertical angles. Whenever you have two angles, and if the only thing that they share is the only thing in common is that vertex, and that would be vertical angles. And number 3, the x angles, two sides, would be this side and this side. And that's on the interior of the parallel lines. The y angles, two sides of the angle, would be there, and that is also on the outside. That's on the outside of the parallel lines. So we've got one angle on the inside of the parallel lines, we've got one angle on the outside of the parallel lines, and they're on the same side of the transversal. That would make these corresponding. So number 3, we know that these are corresponding angles. Moving on to number 4, we are comparing these two angles right here, angle y to angle x, and you can see that, hopefully you see that angle x, two sides are that side and that side. Angle y's two sides of the angle are that side and that side, and you can see they share that side right there. So they have what's called a common side. So whenever two angles have a common side, we refer to those as adjacent angles. So there we go. Number 5. We're comparing angle x to angle y. Angle x's two sides of the angle are here and here. And angle x, if you notice, is on the inside. It's on the interior of the two parallel lines. The two sides of angle y are those two sides right there. So they do share this side in common, but they're not going to be adjacent angles. But if you notice, they're both on the interior and they're on the same side of the transversal. So these would be same side interior angles. All right, same side interior angles for number 5. And you could do abbreviations if you wanted to. So if you said SSIA for number 5, that would be fine. Last one, when we are identifying the angles, we've got number 6. We've got angle x, where the two sides of angle x are right here. We've got the y degree angle, and the two sides of the y degree angle are right there. All right, and you should hopefully recognize that both angle x and angle y are on the exterior. Here's my parallel lines. They're on the outside of the parallel lines, but they are on alternate sides of the transversal. So these are alternate exterior angles, AEA. All right, okay, next problem that you were asked to do, numbers 1 through 7. So in number 7, the instructions say the figures below each show one pair of parallel lines intersecting a transversal. Find the values for x, y, and z when n is equal to -50 and p is equal to +12. Okay, so the first thing that you want to do is you want to take this expression that has the n and the p in it, So the negative 2, but then you're going to substitute in the place of n a negative 50, plus, and then in the place of p, you're going to substitute a positive 12. So that angle would become negative 2 times negative 50, which is positive 100, plus 12, so that's 112 degrees. Okay, so this angle right here that is denoted by the expression negative 2n plus p, that angle is going to be 112 degrees. Okay, well, if that angle is 112, that means the y angle right here has to be a 112 as well. And the reason why y would have to be 112, because y is a vertical angle with this angle right here, which we figured out to be 112. Okay, well then, how would we find, let's find x next. How would we find that? Well, we know that this angle is 112, and if you notice, the y angle, which is right here, and the angle where x is, which is right here, they are, not only do they share a side, so that makes them adjacent, but they're on a straight line. So that makes x and y supplementary. So if you wanted to, so we know that x plus the y angle, which is 112, is going to be equal to 180. If you subtract 112 from 180, that would give you your value for x, which is going to give me 68. So x is going to be 68 degrees. All right, and then how do we find z? Well, if x is 68 degrees, then x and z are alternate interior angles. Remember, alternate interior angles are always congruent, so z would have to be 68 degrees as well. Okay, so that would be my answers for number 7. Next problem that you were assigned was number 9. So in number 9, we're given the lines are parallel, and you can see that the lines are denoted as parallel by those arrows right there. And we're going to find the value of x. Okay, so what you want to do in this problem is you want to take a look at the two angles that have the expressions in them, which would be that angle right there and this angle right here, and then you want to determine what type of angle relationships are those two angles. You notice that these two angles are alternate exterior angles. Okay, well, what's the truth about alternate exterior angles? Remember, the truth is that the alternate exterior angles are congruent to each other. So, because they're congruent to each other, we can take the expression negative 1/2 x plus 12, and we can make it equal to the expression 3/4 x minus 8. So that would be the equation that I would create to find the value of x. Remember, whenever you're finding the value of x, you always have to create an equation. And when we're dealing with these angle relationships, know that there's really only two choices that you're going to have. You're either going to set them equal to each other, or you're going to make them supplementary, which means that you're going to add them together to make 180 degrees. So now I'm going to solve this problem right here. Okay, well, the first thing that I'm going to do in this problem is I'm actually going to multiply the entire problem by the largest denominator. So if you notice, I have a denominator of 2 and I have a denominator of 4. So I'm going to multiply the entire problem by 4. And what I'm going to do is I'm going to distribute the 4 into every single part of this equation. What this will do is, if I do my math correctly, this will eliminate all of the fractions. So the first one, I'm going to go 4 times negative 1/2. Now remember, if you got to think of 4 as 4 over 1. So 4 times negative 1 is negative 4. 1 times 2 is 2. So we would get negative 4 over 2x, which really is just negative 2x. Then I'm going to go 4 times positive 12. Well, that's going to give me positive 48. Equals, then I'm going to go 4 over 1 times 3 over 4. So 4 times 3 is 12. 1 times 4 is 4. So I'm going to get 12 over 4x, and when I divide that out, that gives me 3x. Then I have a minus sign, and then 4 times 8 is 32. So when I multiply everything by 4, you notice I get a new equation, and this new equation is much more friendly to work with because it has no longer fractions. Okay, so now I'm just going to solve for x. So I'm going to add 2x's to both sides of the equation. The left side of the equation has the smaller amount of x's, so let's eliminate them. That would make my equation 48 is equal to 5x minus 32. Then I would add 32 to both sides of the equation. These 32's would cancel out. That would make 48 plus 32, so that would give me 80 is equal to 5x. And then I would divide both sides by 5. So 16 is equal to x. Okay, so there is my answer to number 9. X is equal to 16. Number 10, the next problem that was assigned to you. So what first thing that we're going to do is we're going to look at the two angles that have the expressions in them. So we have the 11 plus 13x angle right there, and that's on the interior of the parallel lines. And then we have the angle where the expression is 15x minus 7, and you notice that angle is also on the interior. So these angles are alternate interior angles. They're AIAs. Okay, well, how do AIAs relate to each other? How do alternate interior angles relate to each other? They're equal. So so what you can do is, to solve for x's, you could take the expression 15x minus 7, you make it equal to that expression, 11 plus 13x, and then we solve that equation for x. Okay, if you notice, we have 15x's on the left, we have 13x's on the right. 13x's is smaller, so I'm going to eliminate the smaller amount of x's. Usually that's a standard way to look at the problems. The 13x's would cancel out. My new equation would become 2x minus 7 is equal to 11. I'm going to add 7 to both sides. The 7's would cancel each other out. I'm using the inverse math operations. My new equation would be 2x is equal to 18. Then I would divide both sides by 2. So my answer to number 10 would be x is equal to 9. Okay, number 12. Looking at number 12, let's take a look at the two angles, and let's see what kind of angles we're talking about, what type of angle relationships we're talking about. So we have this angle right here, which is on the exterior of the parallel lines. Then we have this angle right here, which is on the interior of the parallel lines. So these are corresponding angles. Well, how do corresponding angles relate to each other? If you recall, corresponding angles are congruent. So that means the expression 9x plus 17 minus 3x is going to be equal to the angle that it corresponds with, which is 12 plus 4x plus 5. That would be that expression for that angle. Okay, and now I'm going to solve this equation to solve for x. So on the left side of the equation, I'm going to combine these two like terms together. I'm just going to combine like terms first. So 9x minus 3x gives me 6x, and then I have the plus 17. I have the equal, and then over here on the right side of the equation, I'm going to combine the 12 with the plus 5. Okay, so I'm going to write this as 4x, and then 12 plus 5 gives me positive 17. Okay, now because there's 4x's on the right, and that's smaller than 6x, I'm going to eliminate the positive 4x's by subtracting 4x's from both sides. Those 4x's would cancel, and my new equation would become 2x plus 17 is equal to 17. Okay, now my next step is I'm going to subtract 17 from both sides. And something's going to happen that you guys might not like very much, but it's perfectly okay. Notice these 17's will cancel out. That would give me 2x. And these 17's will cancel out, but I mean, they're going to cancel out, but what are they equal to? Well, they're going to be equal to 0. So it's best if you don't cancel them out and leave nothing there. But if you do cancel them out and there's nothing to put a 0. Now I'm going to divide by 2 from both sides. X is going to be equal to 0. Okay, 0 divided by 2 is 0. There's my answer to number 12. X is equal to 0. Okay, number 14, the next problem here. So in number 14, we're doing the same idea as we were just doing in numbers 9 and 10 and 12. We're going to find the value of x that's going to make the lines parallel. So the way that you want to look at these problems is you want to pretend that the lines are parallel, even though you don't really know it. And then you want to say, okay, because they're parallel, what's going to be true about the 133 degree angle? and the angle that's represented by the expression 5 plus 16x. Well, if you notice, those are corresponding angles. So if the lines are parallel, that means that those two angles are equal to each other. So that means that the 5 plus 16x angle has to be equal to the 133 angle. Okay, and this would only be true if they're parallel. So I'm going to solve for x to see what would x have to be to actually make these lines parallel. Okay, so I'm going to subtract 5 from both sides of the equation. That would make my new equation 16x is equal to 128. And then I'm going to divide both sides of the equation by 16. And 128 divided by 16 is equal to 8. So x has to be 8. Okay, so that's the value that x has to be in order to make these lines parallel. And the reason why that is because if I took this number 8 and I plugged it in, or I substituted in for x, notice this equation would become 5 plus 16 times 8. 16 times 8 is 128, and 5 plus 128 is 133. And that's the only value that x could be in order to make that angle turn out to be 133, which has to be equal to that angle there. Number 15, we're going to do the same thing. So once again, what do? Well, we assume these lines are parallel, and then we take a look at the two angles, and we say, all right, well, if these lines are parallel, what has to be true about the 100-degree angle, which, by the way, is on the interior of the two, what we're assuming to be parallel lines, and the x plus 84 expression angle, which, by the way, is also on the interior. So these two angles are same side interior angles. So what has to be true about these two angles? Remember, same side interior angles have to be supplementary. So what does that mean? It means that if I combine the two angles together by adding them, so if I take the sum of the two angles, they have to turn out to be supplementary, which means that they have to add up to equal 180 degrees. Okay, so I'm going to solve this equation for x. I'm going to combine those two together. That would give me x plus 184 is equal to 180. And then I would subtract 184 from both sides of the equation. And this answer for x might kind of freak you out. Notice we get x is equal to negative 4. So there's my answer. Now, remember, we're not saying that these angles are negative 4. That'd be impossible. We're saying that the value of x is negative 4. And check this out. If I took this expression right here, and I substituted a negative 4 into the place of x, this angle would become negative 4 plus 84, which is 80 degrees. Well, if you notice, 100 plus 80 is 180, which is what I want. So that's the only value that x could be in order to make these two lines parallel to each other. Okay, the last problem that was assigned to you was number 17, and we're going to do the exact same thing. We're going to assume these two lines are parallel. Then we're going to ask ourselves, all right, well, if the lines are parallel, what would have to be true about that angle where the 98 degrees is, which, by the way, is on the interior, and this angle where the x minus 53 expression is, which is also on the interior. So this one, they're same side interior angles. We're going to work it out exactly like we did number 15. Okay, so I'm going to take the two angles, x minus 15. I'm going to take the sum of them, so I'm going to add them together. And same side interior angles are supplementary, so that means they have to add together to equal 180 degrees. Okay, so now I'm just going to solve this. Combine the negative 53 with the positive 98. That's like saying 98 minus 53. So we would get x plus 45 is equal to 180. And then we would subtract 45 from each side of the equation. When I do that, I'm saying my value of x has to be 135. And that's the only value that x could be in order to make those lines parallel. Okay?